I'd like to make a tool probe, and I made a little clamp. I've used this clamp on my other CNC machine. You know, it's kind of shaped so you can grip on stuff. Works pretty good. It's not fiddly like a alligator clip. And then on the tool post here, I also have another wire, like you do with a probe, conductive probe. It turns out that there's continuity all the way from here to here, and there's not really a good way to get rid of it. I mean, I could try to isolate these bolts, but that's going to introduce some rigidity issues. So I don't really know how to do any isolation here. So what I'm going to try to do so that I can get at least automatic tool setup is I'm going to take this shaft, which is slightly undersized 8mm shaft. I'm going to put a sleeve of Delrin on it, and then I'm going to take this and bore it out so that I can slide this over, or slide the Delrin inside this bored out shaft, and then slide the Delrin over this. The Delrin should give me insulation for the path, and then I should be able to do detection tool post setting here. Ultimately, I think I need to make a probe that's isolated that fits into one of my tool holders, because that'll give me work position setting, and I'm probably going to make a mechanical probe to do that. So that's what I'm going to do. And now that this is mostly set up for CNC, we're going to see how this goes. Because I don't really have a way to feed my Z-axis, which sucks. Okay, so I turned this little piece of mystery metal down. I actually just rechucked it, and I've got a dial indicator in here on the middle, or on the inner bore, and I'm reading, about a half a thou of run out. So I think that's pretty decent. Let's see, deeper in the bore we got even less. This end I didn't get all the way through, so I just did a little cleanup pass on the other side. But this is looking pretty good. We got about 3/100ths of a millimeter, which is, yeah, it's I don't know, 7/10 or something like that. There's also some crud in there. I didn't clean out the bore yet, so that's looking good. The fact that I can rechuck it and get it that close is I'm really actually very impressed with this chuck here, because for a crappy lathe, the chuck seems to be really repeatable. So yeah, similar story on the outside, a little more. I had a real hard time cutting the outside. I don't know what this metal is. I think it's just some hot rolled, like A36 or something. But the idea here is this is strong enough not to, so I can clamp it into the chuck, and then it won't deform when I rechuck it. So I've got, I don't know, I think I've got probably about 17.5 millimeters on the outer diameter. I'm like 10.2 on the inner diameter. So I've got a decent amount of metal in there. Hopefully it holds its form. The Delrin will go in, and then my drill rod will go inside of the Delrin. So now what I got to do is go ahead and machine the Delrin to this 10.2 dimension with an interference fit, and then bore it out to 7.92 or whatever this is. So here's the part I made. I just pushed this together. So I had a bit of a hard time trying to bore this. I made the outer diameter first with a very slight taper, so that I could really get a nice tight fit. And so I did the outside diameter, and then the inside diameter. The boring procedure was just kind of pushing the material around. It wasn't really cutting well. So anyway, I reamed like half of it and then pushed it in, and it really doesn't seem to be going anywhere. So again, I've got my drill rod that's been faced off. I've got this, which should be highly concentric inner and outer diameter, and then this insulation, which is essentially gonna prevent my machine from creating a false probe. So I would just go ahead and quickly part this off. Get my parting tool out of the way. And then we can measure it and see how crappy it is. All right. Whoops. I hit the wrong button. Alright, so this is a little proud of that. No big deal. So, flip it around. Gunk in my chuck. Give her some cranks. Grab the measurator. Is any of this in focus? Probably not. All right, here we go. Let's see. So 6, call that 6. Well, it's actually more like, well, 6, yeah, 5.5 or 6. That's about a thou, roughly a thou. Move it out a little bit and see what that tells us. See if the end is worse. A little tiny bit. So I don't know if that is from the re-chucking or something else. It looks consistent. So I'd say this isn't that bad, but I really don't know. I think it's gonna do the mission accomplished, because when I hook up my probe, I won't get a signal and I can do tool touch-offs, and that's what I want to do. So, you know, I have not had I mean, there's a bunch of things going on, I guess. You know, the machine has backlash everywhere. I mean, the best part of the machine is the chuck, really. You know, the all the lead screws have backlash. I have some ball screws. I like being able to run the mill manually or semi-manually. You know, I didn't even know this was going to work. So you know, I mean, there's no easy way to replace this saddle. I mean, it's pretty much garbage. It really should be linear rails or something, because there's so much friction if you want to get decent tolerances. I mean, it's not that much friction, but for the motors, for your stepper motors, you know, you don't want to miss steps, and so everywhere that you have friction is bad. And the amount of friction that you have with linear rails is just orders of magnitude less. The ball screw creates orders of magnitude less friction, less backlash. So, you know, really, I mean, probably the best thing to do with this is to take the head off and mount it on something else, or just use the frame here as a substrate to get some nice machined, registered setup for linear rails and ball screws that give you all the proper clearance, and then block this up so that you have the swing that you want to have. So, but then what do you do with the tailstock? So, you know, tailstock's not hugely useful for CNC operations, but for some, I'm sure that you can use it. So, I don't know. I just want to see if I could get something working, and so, you know, this is working. I guess I'll re-chuck it real quick, just to see what happens. Chuck it in a different position. Chuck it lightly. See what that gives me. Oh, that's worse. So that's 1/10 of a millimeter there. It could be shmoo. There's plenty of that in here. Alright, let me actually move this out of the way. Off. Shmoo. Could be shmoo. Where's my brush? I don't know if I should try to push it up and register it against the face of the chuck, or leave it out a little bit. I think there's probably different schools of thought on which one of those is better. Let's try it again. Here we go. Is that even touching? No. Yeah, that's worse. Oh, I can see it wobbling. Huh. Yeah, I wouldn't call that a win. Try to jam it back in there this time. Should be nice and square on the face. Yeah, 15. It worked better the first time. Huh. Oh, that's weird. Rotate it 90. See what happens. Alright, that's better. Yeah. You know, I can always check it. And again, I don't have any other way to do automated tool offsets other than like put the tool in, like go to work 0, you know, take a skim cut, take another skim cut, take 100 skim cuts. It seems a bit excessive. And then there's like this X ref, Z ref tool. I don't know the difference between the X ref and the Z ref and centroid and the tool offset. Like, why would there be two offsets? But there appears to be two offsets. If you change the Z ref and you change the tool offset, you're gonna get a different tool position than you think you're gonna get. So I'm hoping that the automated tool touch-off procedure will eliminate dumb user error created by me. And so that's that. I guess that's my little project for the day. So yeah, thanks for watching.